All right, let's do some practicing with the empirical rule and the normal distribution. The first couple questions, we're going to refer back to this graphic of women's stature in Anthropology 105 and normal distribution. So these are talking about the heights of women in centimeters. Okay, so number one, describe the class intervals, which is the widths of the bars. Well, it's kind of, if you look, this is 150, this is 160, and there's one in between. So because we know that the width of the bars, they've got to be equal, we know that this one in the middle is 155. So we have, 5 centimeters represented, 150 to 155, 155 to 160, 160 to 165, so on and so forth. So we have 5 centimeters is kind of the width of the bars. Anybody, between 150 and 155 fall in that bar, that kind of thing. What do the heights of the bars represent? Well, if you're not sure and you don't really want to guess, if you look, this piece right here, it says 4 women have statures between 145 and 150. Well, here's 145, 150, 4. So the heights represent the frequency or the number of women in that particular height. Number 3, which class interval has the most women? Well, that's easy. You look at the height, the biggest bar, and then you say, okay, that's 160 to 165. If a woman from Anthropology 105 were selected at random, what is the shortest she could be? Well, that's right here, and that would be 145 centimeters. What's the average height of women? And if you're thinking, I don't know how to figure that out, you don't have to. Look, it says right here, the mean, 163.4 centimeters. You just have to look, right? Graphs are full of data, but you have to look to find it. Okay, and discuss the meaning of the bar at the far right. Well, this is the far right. It's the tallest. It's 180 to 185. It's the tallest woman, and it appears that there is one of them. So we have one tall woman in this class. I mean, that's basically what it means. And I believe it's unusual. So unusual, right, is 2 standard deviations out. And if we take 163.4 and we add 6.7, that's 170.1. If we add 6.7, we're at 176.8. 180 is above that. So this would be an unusual height for a woman. Well, in this class anyway. All right, let's go on to another example. And here we have Professor Ivy collects data on the time it takes for Ivy Tech students to travel to school. She finds that she can model the data with a normal curve. The mean commute time is 27.5 with a standard deviation of 5.2 minutes. Fill out the normal curve. Go ahead and hit pause, try to fill it out, and then come back and see if your answers match mine. All right, so we put the mean in the middle. Remember when you're going to the right that you are going to add the 5.2, and when you go to the left, you're going to subtract 5.2. Even intervals between. Now let's use that to answer some questions. What is the interval of commute times for the middle 95%? Well, remember that 95% is 2 standard deviations from the mean. So here's the mean, 1, 2, so here's 1, 1, 2, here's the other one. So 17.1 to 37.9 minutes would be the interval of commute times. Number 2, what about middle 99.7? Well, that's 3 standard deviations away. So 1, 2, 3, boom. 1, 2, 3, boom. 11.9 to 43.1 minutes. What is the probability of a commute time being less than 17 minutes? Well, here's 17, less is this way. So we've got 2.35% here. This last one is 0.15%. When I add those two together, I would get 2.5%. And no, you do not have to have those memorized. This will be available. The empirical rule chart will be available to you. Number 4, what is the probability of a commute time being more than 38 minutes? Well, this is approximately 38 minutes. More than that is these two spots, 2.35 and 0.15. Because remember, the normal curve is symmetrical. So I end up with 2.5% would be more than 38 minutes. Number 5, based on this data, how many students out of 500 would we expect their commute time to be less than 12? Well, this is about 12. Less than 12 would be 0.15%. So 0.15% of 500. Well, change your percent to a decimal by moving your decimal place 2 to the left, multiply by 500, and we end up with an answer of 0.75. Well, we're talking about people here, so we would round that up to 1. Out of 500 people, we would expect one student to have a commute time less than 12 minutes. Number 6, what is the probability of a commute time being more than 43? Well, here's 43. More is on this side, and it's the outermost region, so 0.15%. And that is your practice on the empirical rule and the normal distribution.